Hey everybody, I'm here for another weekly round of working out some non-calculator free response questions from previous AP Calculus BC exams. We've worked our way through the 2019 and 2018 exams. You can find those um, further on in the feed, but today we're going to work through the 2017 questions. And this particular question is a little bit internet famous for one particular question, which we'll see coming up pretty shortly, about a baked potato. So after the exam, there were a fair number of student complaints and memes regarding the potato problem, and you can look those up at your leisure. But we're going to work through that problem today, and we're going to see what it is about that problem that might have given some people some difficulty, and then how to work that problem in a way that kind of puts your mind at ease. So today we're going to start off with this first question. The first few questions are both A-B material questions. So for those of you taking the BC exam this year in 2020, the likelihood that they show up on the BC exam this year is a little bit slimmer than normal because of the limited nature of the exam this year, but they are still things that are good to know because those topics are all fair game. So we're going to start off with this thing. It's a graph of an f prime. So this is not the graph of f. This is the graph of f prime. I want to make sure that I remember that. And it's differentiable on the closed interval from -6 to 5. It has an initial condition that f of -2 is equal to 7. And f prime is a semicircle. We can see that right over here, centered about the origin, and 3 line segments that are shown up here in this graph. So first thing they want me to do is a relatively simple beginning task, and that is they want me to find two values of f. So that has to do with integrating, finding some area underneath some curves here. But to start that off, we're going to um, I'm going to begin that with trying to find f of -6. And the important thing to remember here when you're doing these types of problems, when they give you an initial condition, which they did here, right? This is the point we know. This is kind of like a stable point that we have in our bag. Everything else after that, all this is showing up here on the screen. All the things up here that they give me in f prime are telling me about how much f is changing. So without this stable point, without this initial condition, I don't really have a lot to go on. With these types of problems, it's really important to do them with a fundamental theorem of calculus. So I'm going to use this number, -2, as part of my fundamental theorem. In fact, for the first one, I'm going to write it's the integral from -6 to -2 of f prime of x dx. So using the thing I want and the thing I want to find, that's going to tell me that I know that's f of -2 minus f of -6. I know what f of -2 is. I need to find f of -6. So I'll go ahead and solve this thing real quick for that. This is going to say that f of -6 is equal to f of -2, which we know, minus the integral from -6 to -2 of f prime. And f of -2 is 7. So we have 7 minus our integral. So from -6 to -2, we have a triangle here. So we just need to find the area of that triangle. 1/2 base of 4 times a height of 2. And we get 7 minus 4, which is 3. So there is f of -6. To find f of 5, same idea. I'm going to go from -2 to 5 of f prime of x dx. That's going to be f of 5 minus f of -2. Again, I know what f of -2 is. I'm trying to find f of 5. f of 5 would be equal to f of -2 plus the integral from -2 to 5 of f prime of x dx. So this time it's 7 plus And I'm starting here at -2. First thing I have is some area underneath the curve. And then I have some area above the curve. The area above the curve is a triangle, base 2, height of 2. Base of 3, height of 2. And then the area underneath the curve, so negative, is pi halves the radius squared. So what we end up with here is 7 plus 3 minus 2 pi, or 10 minus 2 pi is f of 5. Okay, so that's the part A. Then they want to know, when is the function f increasing? And I need to justify my answer. F is increasing when, what's true? Well, it's when f prime is positive. And that occurs, so f is increasing, sorry, I'm going to say therefore, on, let's see, when is it positive? So I'm going to say from -6 to -2, and from 2 to 5. Find an absolute minimum value of f. So critical numbers, f has critical numbers on the interval from -6 to 5 at the places where f prime is equal to 0. So x is equal to -2 and 2 are critical numbers. Now I need to check those places, and I need to check the endpoints. So I need to have some x's and some f of x's. Remember, whenever they're talking about absolute maxes or min, I want to start thinking about a table of values. I want to check my endpoints, in this case -6 and 5, and I want to check my midway points, the places where my derivative is 0 or undefined. I've already found f of -6, it was 3. F of 2 was given to me, it was 7. F of 5 I found was 10 minus 2 pi. And f of 2 is going to be 7 minus my semicircle part. So minus the 2 pi. This means f has an absolute min value of 7 minus 2 pi at x is equal to 2. Last part, for these two values, double the second derivative at -5 and the second derivative at 3, find the value or explain why it doesn't exist. So let's talk about the second derivative at -5. That's happening right here. That's where -5 is. There's the first derivative. To get to the second derivative, I have to think about the slope. The slope of this line is going down 2. It's going over 4. So it's -1/2. So f double prime of -5 is -1/2. But f double prime of 3, let's talk about that one. Well, here it is. There's 3. What's happening there? We're at a corner. So f double prime of 3 does not exist because the graph of f prime has a corner at x is equal to 3. You could also say that the second derivative as x approaches 3 from the left and right are not the same value. Okay, here is our famous potato problem. Let's read this thing one time through, and then we're going to kind of stop and think about it for a second. At time t equals 0, a boiled potato is taken from the pot on a stove and left to cool in a kitchen. the internal temperature of the potato is 91 degrees Celsius at time t is equal to 0, and the internal temperature of the potato is greater than 27 degrees Celsius for all times t is greater than 0. The internal temperature of the potato at time t minutes can be modeled by the function that satisfies the differential equation blah blah blah, where h of t is measured in degrees Celsius and h of 0 is 91. That's a lot of words. Okay, and then again, there's going to come back to the internal temperature of the potato, right? The internal temperature of the potato, the internal temperature of the potato. Frankly, what I think happened is a lot of people got overwhelmed by the language. I think they got overwhelmed by this internal temperature of the potato business. Frankly, though, the problem is not that difficult. The first thing they're asking for, let's just break it down and see what they're looking for first. They want an equation of the line tangent to the graph of h at 0. They want a tangent line. Then they want me to use that tangent line to approximate something at time 3. Well, if they want to start this at time 0, I know at time 0 the temperature of the potato is 91 degrees, so I've got 0, 91. So what am I trying to find here? If I already have the point, what do I need that I have left to get the tangent line is I need a slope. I need what is dh dt at time is equal to 0. Here's my dh dt equation. However, I cannot put in time is equal to 0 into it. So there was a small change. Since I can't put time is equal to 0 in it because time is not a variable in there, what can I do? Well, I can put the other part of the point in there. I know what h is. So I can say, well, dh dt when at 0, 91 is equal to negative 1/4 91 minus 27. 91 minus 27 is 64. 64 quartered is 16, so this is negative 16. Now I have my slope. So now all I have to do is write my tangent line equation. So I'm going to say that means that y is equal to 91 minus 16 times t minus 0, or 91 minus 16t. I want to use that to approximate the internal temperature of the potato at time 3. So I'm going to say h of 3 is approximately what happens when I put 3 in for time into my equation. That's 91 minus 16 times 3 degrees Celsius. I'm not simplifying it. There it is. I've done part A. I've already received some credit from College Board on this problem, which many people had trouble doing. The average score for this problem was depressingly low. If I remember correctly, it was less than 2 points, but it's been a while since I've looked at the statistics. Use the second derivative of h with respect to time to determine whether or not your answer in part A is an underestimate or an overestimate. When they start talking about using the second derivative to determine underestimates and overestimates, what we need to be thinking about is how does concavity affect our tangent line approximations. Basically, if I have a concave up function and a tangent line, then I'm an underestimate. If I have a concave down function and a tangent line, then I have an overestimate. So I need to get a second derivative. So the first thing I'm going to do is take the derivative of the equation they gave me. When I do that, that's going to give me negative 1/4. The derivative of h minus 27 is dh dt. You remember, when you're taking the derivative of this thing with respect to time, because time is my variable here that I'm taking the derivative with respect to, I'm going to end up with this is not a t, therefore it's going to end up with a dh dt. It's 1 dh dt, right? A little bit of implicit differentiation. That means this is negative 1/4, right, of whatever dh dt is, which I already have is negative 1/4 h minus 27. Okay, so that would be equal to 1/16 h minus 27. Well, 1/16 is always positive. What about h minus 27? Well, it's positive as long as h is greater than 27. It's negative if h is less than 27. But what do I know? I know that the temperature of the potato is greater than 27 degrees for all times t greater than 0. So what I'm going to say is, since h is greater than 27 degrees Celsius for all t greater than 0, d2h over dt squared is greater than 0. And that means that I was a concave up function, which means the approximation is an underestimate. Okay, last part of the problem. When time is less than 10, there's an alternate way we can look at the temperature of the potato. We've got this dGdt thing, where G is measured in degrees Celsius and G0 is 91. They want me to find an expression for G of T. To do that, we get to do our favorite thing. It's a separable differential equation. And I end up with 1 over G minus 27 to the 2/3 dg is equal to negative dt. I left the negative over there. It makes me happier to leave something on the other side. I didn't want to really move the negative over. Oftentimes it kind of leads me to mistakes. When I integrate this thing, we're going to end up with our g minus 27 being to the 1/3 power times a 3. That is going to equal to negative t plus a c. So I've separated, I've integrated. I did not forget my plus c, right? Separate, integrate, don't forget your c. Okay, so we did that part. And now I'm going to use my initial condition so I don't lose my credit there. So we've got 3 times at time equals 0, g is 91. So I got 91 minus 27 to the 1/3 power is equal to c at 0.91. Okay, so what this means to me is 91 minus 27 is 64. 64 cubed rooted is 4. 4 times 3 is 12, so 12 is c. That means that my equation would be 3 times g minus 27 to the 1/3 is equal to negative 12 plus c. I'll divide both sides by 3, get g minus 27 to the 1/3 power is equal to negative 4 plus, oh wait, I messed something up. I did mess something up. Not negative 12 plus c, excuse me, negative t plus 12. Now divide by 3, goodness gracious. G minus 27 to the 1/3 is equal to negative 1/3 t plus 4. Glad I caught that. Alright, cube both sides and add 27 over. I'll get g of t is equal to negative 1/3 t plus 4 all cubed plus 27. They want me to use this to approximate the internal temperature of the potato at time 3. So I'd say g of 3 is approximately negative 1/3 times 3 plus 4 all cubed plus 27 degrees C. Again, I would not simplify. Moving on to the next problem. This begins our BC material. This is a perfectly good problem. Nothing in here to me seems out of place. Okay, not even on this year's exam. It all seems like fair game. So we're going to find the slope of the line tangent to the graph of f at x is equal to 3. So first thing I'd like to do is find out what f of 3, find out what the derivative of f is. So f prime of x is equal to, let's see, since this was all 3 times 2x squared minus 7x plus 5 to the negative 1 power, when I take the derivative, I'll end up with a negative 3, 2x squared minus 7x plus 5 to the negative 2 power, all times 4x minus 7. When I try that at 3, f prime of 3 is going to equal to negative 3 times, I'll put 3 into this thing that's staying in the numerator. That's 3 times 4, which is 12, minus 7, which is 5, all divided by whatever this stuff is at 3, which is 9 times 2, 18. 18 minus 21 is negative 3. Negative 3 plus 5 is 2. So we end up with negative 15 halves. Okay. Find the x-coordinate of each critical point in the interval from 1 to 2.5. If you look at this thing, it factors. They actually show us the factoring of it down in part C, so you can kind of see down here. But there are the denominator of both my original function and my derivative both factor, but the only thing that's in the interval that they care about is going to be whatever makes this thing equal to 0. So what I'm going to do is I'm going to set 4x minus 7 equal to 0. That gives me that x is equal to 7/4. This is the only place where I might have a maximum, a minimum, or neither. And it's definitely going to be because of the multiplicity of this root, because it's only to the first power here. We talked about that in class, talking about repeated roots. It's definitely going to be a minimum or a maximum. I just have to find out which one. So what I need to do is find out what's happening on either side of 7/4. And if I can find out what's happening on one side, I know what's happening on the other side due to multiplicity's sakes. So it turns out if I put in something like 2 into here, I will find out that what I end up with is something that's negative. So this function on one side of 7/4 is decreasing, on the other side of 7/4 is increasing. I can say that it is that f has a relative maximum at x is equal to 7/4 because f prime of x changes from positive to negative at that value. All right, let's come on down. Let's do a little improper integral. A little integral we can't take home to mama. All right, we got our, they went ahead and showed us how the partial fractions would break apart. So all I really have to worry about is doing my limit as b goes to infinity. The integral from 5 to b. I have 2 over 2x minus 5 minus 1 over x minus 1 dx. When I integrate this thing, I will end up with the limit as b goes to infinity of the natural log of the absolute value of 2x minus 5 minus the natural log of the absolute value of x minus 1, all evaluated from 5 to b. That is, the limit as b goes to infinity of the natural log of the absolute value of 2b minus 5 minus the natural log of b minus 1 minus the natural log of what happens when I put in 5, which is the natural log of 5 minus the natural log of 4. So we have the limit as b goes to infinity of the natural log of the absolute value of 2b minus 5 over b minus 1 minus the natural log of 5/4. And as I take this limit, now look, it was really important that I combined those two things using log rules. It would have been difficult for me otherwise to determine this limit. But now that I have the limit in this way, I can see that as my b is going to infinity, I have a Betsy situation here. And that's going to give me a limit of 2 on the inside, so I'll end up with a natural log of 2. end up with the natural log of 2 minus the natural log of 5/4, and I'm going to leave that there. That is my answer. Then they asked me something that is very much related to what we just did. They said, hey, if I turn this thing into a series from 5 to infinity instead of an integral from 5 to infinity, does this series now, does it converge or does it diverge? And what I can say is, since f of x equaling 2x squared minus 7x plus 5 is positive, continuous, and decreasing on the interval from 5 to infinity, then I can say that, and the integral from 5 to infinity of f of x dx converges. The series in going from 5 to infinity of 3 over 2n squared minus 7n plus 5 also converges by the integral test. I had to show them the conditions. They did mention that I needed to talk about the conditions, but I should use the conditions by default even if they do not ask me for them. We want to get in a good habit of setting up conditions so that we don't get left out. All right, last problem. All right, this is the series question for this year. For this, they've given me a formula at the top to determine derivatives of 0 of the function f. And the first thing they'd like me to do is they'd like me to show that the first four non-zero terms of our Maclaurin series are x minus x squared over 2 plus x cubed over 3 minus x to the fourth over 4, and they want us to find the general term. So I need these derivative values now. I mean, I have the function value and I have the first derivative, but I need to get to the second derivative at 0. Well, the second derivative at 0 is going to be negative 1 times the first derivative at 0. So since the first derivative at 0 was 1, this would be a value of negative 1. The third derivative at 0 is going to equal negative 2 times the second derivative at 0. So that's going to equal positive 2. And to get the fourth term, which is what I need, 4 non-zero terms, the fourth derivative at 0 is going to equal negative 3 times the third derivative at 0. So this is going to be equal to negative 6. And so what I would end up with when I work out the Maclaurin series is I'd end up with 0 plus x minus x squared over 2 plus 2x cubed over 3 factorial minus 6x to the fourth over 4 factorial plus dot dot dot. And when I start simplifying that out, what I end up with is x minus x squared over 2 plus x cubed over 3 minus x to the fourth over 4. And when I end up with this, I see that this is an alternating series, so negative 1, and it'd be to the n plus 1 to get to the negative on the right spot, x to the n over n. Whatever the power of the x is whatever I have in the denominator. I want to determine whether or not that Maclaurin series converges absolutely or conditionally or diverges when x is equal to 1. So the series we're talking about here, when x is equal to 1, is negative 1 to the n plus 1 over n. Because if I put 1 to the nth power, I just get 1. Well, this series itself converges by the alternating series test because it's the alternating harmonic. It's one way you could think about it. But if I take the summation of the absolute value of that, I get the series 1 over n, which diverges. So this series, negative 1 to the n plus 1 over n, converges conditionally. To check to see if it's conditional or absolute, I have to make sure that both the terms as given and the absolute value of all the terms would both converge. So I had to check it with both as it was originally given. If it had diverged, I was done. I could just get out of there. But if it converges, then I need to check to see if the stronger level of convergence also holds true. So I had to check to see if the absolute value of the terms also converged. Okay, let's get down to part C. I want to find out if the first four, I want to find the first four non-zero terms and the general term for g of x, which is the integral from 0 to x of f of t. Alright, so since I know g of x is the integral from 0 to x of t minus t squared over 2 plus t cubed over 3 minus t to the fourth over 4 dt, I know that that is equal to x squared over 2 minus x cubed over 6 plus x to the fourth over 12. I'm just integrating these things term by term, putting in the x and subtracting out the zeros. All the zeros would go away. In this case, minus x to the fifth over 20 plus dot dot dot. And if I integrate the general term, so let's look back up here at the general term, it would integrate into negative 1 to the n plus 1, x to the n plus 1, all times n times n plus 1. There it is. I have done part C, just integrating term by term of the series I already had. Part D is one of those things that oftentimes scares people, but it's probably one of the easier mathematically to do problems on the exam. And that is, they start talking about error bounds. And anytime they start talking about error bounds, people freak out. But if you'll remember from class, the alternating series error bound is like the best one. And it basically says that we know our error is less than or equal to our next term. They want us to show that it's less than 1/500th. So what are they using here? They are using a fourth degree term. So for me, I need to be thinking about what is the fifth degree term. That's the next term up. Where are they checking this thing? They're doing it at 1/2. So I'm going to say, look, I know P4 of 1/2 minus G of 1/2 has to be less than or equal to what happens when I take the fifth degree term and evaluate it at 1/2. So that would be 1/2 to the fifth over 20. That was our fifth degree term from above. Well, this is 1 over 32 times 20, which I know is less than 1/500th. All right, guys, we have done it. We have worked through all of the problems for the non-calculator part of this free response. We did so in just over 30 minutes. You would have had an hour on the exam. I hope this was useful for you. If you have any questions, of course, obviously leave them below or send me a message. And best of luck, guys. Keep studying.